Right now, literally deep beneath your feet, some truly unprecedented geomagnetic anomalies are unfolding. Welcome to this explainer. Today, we're diving into Earth's magnetic North Pole and the mystery of why it is moving, well, incredibly fast. It's not just slowly drifting like scientists originally expected, and it's definitely not following the careful models we built just a decade ago. It's actively accelerating. And now, in 2026, that rapid movement is exposing some pretty major gaps in our understanding of what's actually happening inside our own planet.
The 2026 data we're getting shows a total failure of our predictive models. And honestly, that is a massive deal for geophysicists. The recent movement just isn't lining up with projections from even 10 years ago. And that reality is forcing experts to rethink everything they thought they knew about the massive, hidden geodynamo that protects our planet. By analyzing these unprecedented shifts today, we're going to uncover just how little we still understand about the very ground we stand on and why these current deviations are totally pushing the boundaries of modern Earth science.
Okay, let's dive right in. Section 1, the accelerating North Pole. To really grasp the sheer contrast of the 2026 anomalies, we have to recognize that the pole has never been a fixed point. It's always moved. If we look back at the 20th century, it drifted slowly across northern Canada at a relatively calm, leisurely pace of about 10 to 15 kilometers per year. There was no drama. It was a smooth, entirely predictable stroll. But around the early 2000s, the physics shifted. It started speeding up dramatically. By the 2010s, this acceleration hit upwards of 55 kilometers per year. This meant scientists were already having to update global navigation models way faster than they ever anticipated. And that brings us to 2026, where we are now recording highly unusual anomalies and a sudden geomagnetic jerk. We have literally gone from a slow drift to a full-on sprint.
Now, jumping from 15 kilometers a year to over 55 kilometers a year might not sound like warp speed to you or me, but in geophysical terms, that is an incredibly violent acceleration. It's so fast that it has actually forced rare, unscheduled updates to the world magnetic model. But what's really capturing the attention of researchers right now is the trajectory. Instead of a smooth, straight drift, the path has become totally erratic. We're tracking unexpected variations in both direction and velocity. The magnetic pole is behaving less like a steady pendulum and more like a chaotic one, taking this highly irregular path that just refuses to map onto our established projections.
So, who are the suspects here? Let's move to Section 2, the core tug-of-war. To actually uncover what's behind this rapid movement, we have to shift our investigation downward. To really grasp the mechanics here, we need to take a journey deep underground, 3,000 kilometers below the crust. Down here, Earth's magnetic field is generated by the geodynamo within the outer core. And this isn't just a static, quiet pool of metal. It is a roiling ocean of superheated liquid iron and nickel. Driven by extreme convection currents and twisted by the Coriolis effect from the Earth's rotation, this unimaginably powerful fluid motion generates the electromagnetic field that surrounds us. Now, just imagine localized parts of that intense underground flow suddenly altering their velocity or their trajectory. That is exactly what's happening to drive the changes we are recording up here on the surface.
We can basically think of this fluid interaction as a massive subterranean tug-of-war. There are two key magnetic lobes, or flux patches, driving the field in the northern hemisphere, one sitting right under Canada and one under Siberia. For years, these two regions balanced each other out in a fairly stable standoff. But recently, the fluid dynamics have fundamentally altered. An elongated jet of liquid iron circulating in the outer core has disrupted the magnetic patch under Canada, causing it to weaken significantly. Meanwhile, the Siberian side is maintaining its strength, or maybe even intensifying. Because of this shifting balance of hydrodynamic forces, the magnetic pole is literally being pulled across the geographic pole towards Siberia. You are watching a real-time shift in planetary fluid dynamics. And this brings us to early 2026, when scientists observed what's called a geomagnetic jerk. Let's break down exactly what that means. A geomagnetic jerk is a sudden, unpredictable change in the acceleration of the magnetic field. Now, actually, scratch any doomsday scenarios you might be thinking out. It does not mean the magnetic field has flipped, and it certainly does not signal a planetary catastrophe. Rather, it indicates a rapid, localized acceleration in the flow of liquid metal within the core. Think of it like a sudden eddy or whirlpool forming in a fast-moving river. These jerks propagate upward through the mantle and register on our surface instruments as sharp, V-shaped deviations in the magnetic data.
Which leads us straight into Section 3 when our models struggle. This is a rather humbling reality for the scientific community, and it's exactly why the 2026 data completely caught us off guard. Look, our mathematical models of Earth's interior are incredibly sophisticated, but they are limited. We can't physically drill down 3,000 kilometers to drop sensors into the outer core. Instead, we rely entirely on indirect data. We use specialized orbital arrays like the European Space Agency's swarm satellites to measure the magnetic field from space, and then we essentially reverse engineer what must be happening underground. But because fluid dynamics in a spinning, spherical, superheated core are inherently chaotic, mathematical simulations can only project so far into the future. When a geomagnetic jerk occurs, the math breaks down, and our models just naturally lag behind the messy reality of that liquid iron flow. All right, let's bring this explainer back up to the surface with Section 4, Real-World Impacts and Reversals. Why does a deep Earth fluid anomaly actually matter to your everyday life? Well, the World Magnetic Model is the invisible software backbone for all modern navigation, commercial aviation, military submersibles, international shipping, and yes, even the compass app in your smartphone all run on it. Because the pole is racing towards Siberia faster than predicted, these systems require emergency, out-of-cycle updates to prevent navigational drift. And the impact is highly tangible. Airports are literally having to repaint the massive numbers on their runways because runway designations are actually just compass headings, and they are now drifting out of alignment. Researchers are also closely monitoring how this rapid shift affects radiation exposure modeling at high altitudes and whether migratory birds and sea turtles are being forced to adapt their own internal navigation. It's a huge domino effect. Now, whenever we track rapid anomalies in the magnetic field, we absolutely have to address the inevitable question, are we heading toward a complete magnetic reversal? From a strictly scientific standpoint, the answer, based on current source data, is that we simply don't know when the next one will happen. Earth's magnetic poles have indeed swapped places hundreds of times throughout geological history. But these reversals, they are not sudden events. They typically take thousands of years of gradual weakening and chaotic multipole phases to complete. So while the localized weakening under Canada is completely fascinating, current geodynamo models show absolutely no solid evidence that a full global magnetic reversal is imminent in our lifetimes. Ultimately, what the 2026 data represents is not some glitch in the matrix. It's a feature of an incredibly complex planetary engine. We are witnessing a dynamic system behaving dynamically. Earth is vastly more intricate and active than our clean mathematical projections sometimes account for. The magnetic field is not a static, fixed shield bolted to the crust. It is a living, breathing, electromagnetic ecosystem. It's continuously generated, distorted, and sustained by immense hydrodynamic forces swirling deep in the dark, inaccessible heart of our planet. The anomalies we are tracking right now serve as this incredibly powerful reminder. If you want to understand the future of this planet, you don't just look up at space. You have to look down. The deeper we analyze, the more we realize how deeply connected our modern, surface-level technology is to the deep Earth fluid dynamics churning thousands of kilometers below us. And it leaves us with this final, kind of wild thought to consider. If the very ground beneath us, the magnetic anchor we've relied on for centuries to find our way, isn't completely predictable, what is? Thank you for joining me for this explainer. Keep asking those big questions, and I'll see you next time.